Welcome to Coding Talks with myself, Vishnu VG. Coding Talks is a technology podcast which is available on all podcast platforms. The topic of today's discussion is about containerization, its benefits for the business and organization, how it can help the application development, what are some of the benefits, and also we are also going to look into some of the services that AWS provides in terms of containerizing your application. Now, prior experience about containerization is required. This will be a discussion about the containers. We will start from the scratch and then we will look into more advanced ways of deploying the container platforms like the Kubernetes. So myself, a .NET programmer and cloud architect from Thiruvananthapuram, Kerala state. I do have an YouTube channel and also a meetup group called Coding Talks Cloud Computing. You can connect with me on LinkedIn. My LinkedIn profile is Vishnu VG TVM. You can check out on that podcast show notes as well. So thank you once again for listening this podcast, and we'll start right away. All the opinions that I expressed through this podcast are purely personal and do not represent any of the employer's view in any way. With that, we can start today's session. The session is about containerizing. Containerization generally says it's a kind of a software deployment model of packaging your application code, its dependencies, configurations, everything that is required for running your application as a self-contained, very modular, self-sufficient package so that you can deploy it much easier. In earlier days of software development, we use some form of traditional deployment strategies, including installing the dependencies in advance before your application gets deployed. Nowadays, with containerization, we as a software developer or operations team don't have to bother anything about the infrastructure at all, and they can simply deploy on demand. So that means they can save some cost. So instead of figuring out all the dependencies during the application deployment time, now the shift is towards identifying the dependencies during the application development itself. So the developer can figure out what all dependencies are required at the time of application development itself. They can containerize by adding simply a Docker file. There is a structure to follow in the Docker file, which is very easy. So once they add a Docker file with all the required details, and that means they are containerizing the application, and the application developer is actually controlling the application how it should behave at the time of development itself. So this is the process of containerization, and once that is in place, they can hand over this to any other platforms. So it can be their development laptop, and also it can be some form of cloud service like AWS or Azure. It can also be deployed on other platforms as well. It can be on data centers, virtual machines, then IoT devices, anywhere. Wherever there is an provision which has an container runtime in place, which most of these cloud services nowadays do have, they can deploy the application without bothering anything about the dependency management at all. So that means the application itself is fully sufficient. Now, what type of application benefits from this form of deployment or the container form of deployment? Mostly non-monolithic applications, especially nowadays the enterprise applications do follow a pattern called microservices architecture, where instead of having a single monolithic application in place, it's architected with a lot of modular containerized application connected to each other through network. So this network interface can be either a REST API or it can be gRPC. It can also be through some form of cloud native integrations like a service bus or queue mechanism. So that means instead of having a monolith application, you could imagine your application as a series of or interconnected modular standalone application. Each one is containerized and it can be deployed independently. It can be scaled independently, and these all different modular applications connect with each other through some form of network interface. So the choice is up to the software architect. It can be a REST API if they want some synchronous form of communication, or in most of the case, if the architect architects the software architecture in a way to work in an asynchronous fashion, it can be relied on some form of a queue mechanism or a service bus integration as well. So that's about the architecting part. But basically you can simply think of it as a kind of an set of different services, modular services, interconnected each other. So when if your application have a fewer or lesser set of micro services like this, it will be easier to manage by yourself. But in case if you have a lot of containers, especially multiple containers, more than 20 or 30, then some form of orchestrator or some form of a mechanism to manage this container is also required. Such a mechanism is one of the most popular mechanism is the Kubernetes, and many cloud providers are already adopted that Kubernetes version in their services, and they have their own versions. If you look into Amazon, there you can see the Amazon Elastic Kubernetes version is there. Similarly, Amazon also have Amazon Container Service, and Red Hat also provides a version of their own Kubernetes integrated with the different pipelines and all, which is called the Red Hat OpenShift, and AWS also provides that. So similar way, lot of different cloud providers have their own versions. Similarly for Azure and GCP as well. In this episode, we will be mainly talking about the containers from perspective of AWS, but you can relate that with any cloud providers as you like. Then, so this means developers are in full control of developing a application, including its dependencies, by containerizing it. They usually test that on their local system using some form of a software called Docker Desktop or Postman or Rancher. So this is in case of simple containers. What about enterprise level applications which need scalability and needs Kubernetes? In that case, developers can use Minikube, which provides a local development setup for simulating the Kubernetes, which runs on a single cluster on a local system. So all these softwares are available on different platforms, be it Linux or Mac OS or Windows. The Docker, one thing to remember in this case is that the Docker Desktop is one of the convenient ways to run a Docker application in your local system, and it has integration with most of the IDEs like Visual Studio Code and Visual Studio Professional as well. Only thing is recently the Docker Desktop has changed their license model and they moved to a paid version. That means if your enterprise has more than 250 employees, then you need to have a paid version of Docker Desktop. Alternatively, you can use a free tool called the Postman, which is free for all the platform, but that needs a little bit of configuration. If you are having Windows system, you need to install the WSL in advance for installing the Postman, and using a command. Once you have Postman in place, and if you have a application, a Dockerized application, then you can simply spin it up using a command. So if it is a Docker, then you can use a Docker run and followed by that command. So this is the usual pattern of how developers develop an application using the containerization technologies, and once that is in place, then they hand over this to the other environments. Usually the handover happens through the pipeline. So usually they commit the changes, everything including their application along with the Docker file into a code base. So this is the way of having everything in code, so that you can control, developers can control everything from the code level. Then various pipelines, build and deployment pipelines are set up, and the continuous integration and continuous deployment will be set up using some kind of form of a deployment model, and then it will be, the corresponding code will be deployed to the whatever environment that you want to deploy it. So usually when someone heard about the containerization of application, Kubernetes will be the first picture that comes into mind. So just keep in mind that Kubernetes is a kind of an advanced version. With its it offers a rich set of features like scalability, self-healing mechanism, its own persistence, and lot of other additional features, but it do cost more as well. So if you have an application to be run on, and if you want to simply containerize an application, say for example if it's a batch processing job or something, you do have other options from the cloud services as well. Kubernetes is a bit higher version and it costs a bit extra as well. So cloud providers do offer multiple services, not just the Kubernetes. Kubernetes, it's actually developed by Google and initially, and then they handed over that to the Cloud Native Foundation, and Cloud Native Foundation is the one which mainly manages this Kubernetes, and many open source providers including AWS adds features on top of Kubernetes, so that cloud provider will manage that and you don't have to bother anything about the maintaining the infrastructure of the Kubernetes or clusters. You can just have a kind of a declarative configuration for the Kubernetes, and everything will be taken care of by the cloud provider. Only thing in this context is if you are using some form of cloud version of Kubernetes, the management will be much easier because cloud manages that, but you need to pay additional for that as well. But that will be the first choice for the enterprises, because managing the Kubernetes by our own infrastructure will be a challenge and it requires expertise as well. Then having lighter versions of containerization services, something like the AC, the Amazon Container Service, or other forms of services can quite helpful if you don't want a Kubernetes version in cloud. So now we will look into some of the use cases of the containerization, why we want to do that. We already discussed on benefit, like the application developers how gets full control over how their application will behave in all different environments. So that means if I develop an application with a Docker file and I containerize it, I decide how the application will behave in all the different environments. No one else, like the ops or even the cloud provider, have to bother about its dependencies and all. That will be taken care of by the cloud, the container runtime. So everything related to the dependencies and everything related for running that application, including its runtime dependencies, everything will be declared in the Docker file itself. So it will be, if you open an existing Docker file, to get a view of how this will looks like, you can simply create a new .NET Core application using your Visual Studio environment. And while creating the project, you do have the option to check a box called add a Docker file or containerize this application, and then Visual Studio will automatically add a Docker file on behalf of you, and then that is in place. So if you open that, you can see they are using some base image, then based on your application needs. So if you are adding more dependencies, you may have to alter the Docker file in such a way as to add more dependencies. But if it's a simple application with a simple .NET Core without any external dependencies, then you can have that whatever that is provided by Visual Studio for running your application. So this varies depending upon your application. So if it is a JavaScript application, then the strategy will be a bit different. Docker file will be there, but instead of the entries that you can see as in a .NET Core application, that will be different. And similarly for Python application, it will be different. Main point is, whatever your application, irrespective of your application, you can Dockerize it. Then this is best suitable for microservice architecture. So microservice is a form of an architecture where your application will be composed of small modular services interconnected with each other. So if you have an architecture in place like that, then container will be a better choice for that. There is another one deployment option also called the serverless as well, which is a way of deploying the application without you bother much about how the dependencies will be resolved. Everything will be taken care of by the cloud vendor itself. So that is another strategy. So the containers and the serverless, these are two different strategies which you can leverage for deploying the microservice architecture. Containers are best suitable for microservice architecture. That doesn't mean like you can only containerize a microservice architecture based application. You can even simply containerize any type of application, but microservice provides or it has certain characteristics like modularity. The application will be much modular. It does a simple function or service by itself without having multiple responsibilities, and will be owned by a team. It has its own code base, it has its independent data store, and one of the most important benefits that a microservice provides is independent deployability. You can deploy that service without altering or touching any other part of the application. So independent deployability is one of the key criteria of the application of a microservice architecture, and to have that in place, you need an independent data store as well. So the architecture of the microservice will be a bit challenging than the monolith application, but if you have such set of a certain number of microservices which form your application, then this containers will be a better choice for that. Of course, you can deploy your microservice in any platforms. You can deploy that in serverless, or you can deploy that in virtual machines as well. But deploying that virtual machine would cost additional charges. Virtual machine by itself, like EC2 instances, are a bit costly. And containers are very lightweight compared to the EC2 instances. It's very minimal, and you can have multiple containers inside a single VM with its own boundary and all. So that means all the characteristics that you want in a microservice architecture, like the boundary, isolation and everything, it can containers can ensure that. So if you have an existing application, then architecting that to microservice would be a bit challenging. Microservice architecture focus on a particular business domain, and there are certain practices like event storming or discussions around what kind of service your microservice needs to provide. So these all can help to arrive a decision, and you can find out a domain for your of your application, and you can plan to implement that domain as a microservice. Then this is especially suitable if you are converting your existing application to a microservice, existing monolith to a microservice. But there are some other business cases as well. Like when you start to develop a new application, then think about whether the application can have the possibility of scaling independent parts. Then you could consider that parts to be a microservice. So this is not a microservice focused session, but still we are covering some of the areas of microservice a bit more in this session as well, so that you will get an understanding how containers are best suitable for that. So the independent deployability is one of the characteristics of microservice, and independent scalability is also another characteristics of a microservice, and containers do provide that, so that you can independently scale a container instance as you like. So if you look into the Kubernetes deployed application, you can alter a container instance, and you can even set up automated scale up and scale down based on certain criteria as well. You can if it is in a cloud service like the EKS or some form of container service in cloud, they provide some options to scale up your application based on certain criteria, like maybe it can be some form of user request or some form of CPU usage. You can set this so that your application will automatically scale up whenever it is required, and when it is not required it will automatically scale down. And there are cases where you need sometimes the container instance may crash, and automatically the container platform will automatically create another one on behalf of you, and it will whatever you are defined for the container platforms, it will be automatically taken care of by that container platform itself. So that is why the Kubernetes is called a kind of a declarative model, where you define how many clusters you want, how many pods you want, how much RAM each pod should consume, and based on that it will automatically handle your application instances on behalf of you. And these all runs independently. So using some package mechanisms like a Helm, you can package your entire application container instances using Helm, and then you can deploy that to Kubernetes, so that Kubernetes will manage each container instances independently based on how you configured. So these are some of the benefits that it offers, mainly independent scalability. So that means if some part of your application requires some extra work in some certain scenarios, then you could scale up as required and scale down whenever it's not required. So cost benefits you will also get. Then there are not special hard or fast rules, like you cannot use containers for a monolith application. Most of the cases, especially when an enterprise wants to convert an existing application to cloud native, then they start with a lift and shift migration, where they pick the entire application into the cloud in some form of a VM or some other service, and then they will extract one by one the different services which have the scope for scalability, and then converts each part of such domains into different microservices. So that's the process of containerization. So this is in the case of an existing application, existing monolith or legacy application that enterprises wants to convert. But if it is in the case of a new application, an architect has to decide whether this application can be containerized or not. If it's not required, then it can be deployed on some other forms of services in the cloud. But if there is a scope for independent scalability, then it will be a good option to start with the containerization. One another benefit that I can feel when it comes to containers is that if you develop a container application, if you have a set of container application, you can deploy that to any platforms as you like. So that means if you want to have some multi-cloud pattern of deployment, you can have that, and also you can deploy that on a data center, provided if there is a container runtime there, or you can also deploy on edge devices as well. Certain services like the OpenShift and all provide edge capabilities. AWS also provides edge capabilities so that you can deploy your container applications on whatever environment, even in the data centers. You can deploy that, and wherever it's required, you can have that. So this is especially helpful in the case of machine learning and other artificial intelligence scenarios where you need something from the client end, and you need to have some form of an application running there within the client infrastructure without sitting in the client, so that you can collect the relevant data from there, and using some form of batch-based mechanism, you can collect that to a central mechanism. And then so all this, the point is all this containerization to provide some form of a way to handle that. Then the which service to use, that part we are going to discuss now. So there, if you plan to start with containerizing an application, think about the scope of how much it can scale up and scale down. So if it's a simple service, which a few set of services, then you don't have to go with an orchestration mechanism like Kubernetes. In that case, you can go for simple container services within the cloud. Most of the cloud do provide these. So we are going to discuss some of these services. First one is the Elastic Kubernetes services or the Red Hat OpenShift services. Then similar to this, Amazon container services. So all these are somewhat common. They do have some differences which depends on each of these vendors. But basically the Elastic Kubernetes service is a version of Kubernetes which provides advanced orchestration and scalability features, and AWS will manage it on behalf of you. So you as an whether you are a developer or you are an part of an operation team, you don't have to bother much about the how the clusters are managed and all. Everything will be taken care of by the cloud vendor. In this case, it will be Amazon will be taking care of that. So this will be ideal for scenarios where you have a lot of containers which requires independent scaling, orchestration and logging as well. Then this Elastic Kubernetes services or Amazon Container Services both provides options to run scheduled container jobs which can be triggered with the KDA. So the pricing will be a bit higher compared to other forms of services, because most of the cloud providers will charge a fixed plan for the control plane and the variable cost for the worker nodes and services. So that means if you have a lot of clusters which you require based on how you want your application to scale up and down, then they will be charging accordingly. So when it comes to containers, the pricing model for Kubernetes will be on a much higher plane, but it benefits, or it's suitable for certain organization where if they want to have independent scalability and other features like independent logging and other not independent logging, orchestration, scaling, and persistent storage and other features, then Kubernetes will be a better choice, provided if you have that budget in place for the project. Then second set of services is on a bit lower level, but it provides some kind of serverless features. So that service is called AWS Fargate, which is available from AWS. AWS Fargate is suitable for container scenarios where you don't have to bother much about the Kubernetes level configuration, or you don't have to bother much about managing the different servers at all. So in the case of serverless, the cloud provider will manage everything, like the scalability, the availability, and also the logging. Everything will be taken care of by the cloud provider. You just have to configure that how you need, but the scalability and everything will be taken care, and you will be, most of the serverless services will be having a kind of a compute model pricing, where based on how you are actually using the service, they will be charged accordingly. They do also provide a provisioned pricing model as well, so that if you want a provision model or a fixed, if you are sure that you will be using that service for a certain period of time, then you can have a provisioned model as well. Then there are some limitations of most of the serverless services do have, like it needs certain time to spin up. So this is called the concept of cold start, where based on demand they spin up the resources. So that means it will take a little bit of time, but you do have the way of kind of a provisioned start in place, so that it will be warmed up a bit in advance, so that the boot up time can be made minimal in that case. And there are other mechanisms also. By implementing some form of asynchronous interaction in between, you can minimize the time there as well, or you can architect the solution in a bit different way. So instead of waiting immediate response from the service, you can place some queue or some service bus in between, so that the service don't have to reply immediately. But there are certain cases where, especially in the case of the APIs and all, you do need to revert back immediately. So in that case, you do need a provisioned service as well. So the containers can run inside the serverless mechanisms as well, and that kind of service is called the AWS Fargate. The benefit is that you can integrate this with the other services like the AWS Lambda, which is another serverless service, or EK. So that means if you have a certain set of batch jobs which you are sure that it will run within a certain period of time, then it will be better to go with a kind of a serverless kind of pattern, so that you can have some service in place and it will spin up whenever it is required. So especially suitable good for batch jobs. And the benefit you get from this kind of model is the zero server management, independent scalability, inbuilt scalability, then fault tolerance as well. Then most of this kind of model, like the AWS Fargate, or whatever other services which different cloud providers provide, they do provide most of the features by themselves. So means if you have a code repository in place, these services will provide features to connect to that repository and pull the image and run on behalf of some kind form of a filter like a branching pattern or some other criterias. Then you can also pull that from a container registry as well. Usually in the case of containers, once you add a Docker file, then at the time of application build, mostly this will be handled using the pipeline. Then that application will be stored inside a registry, and then during the deployment time, the deployment pipeline will pick the modular container application from the registry. So that's called the image. A container image is what we call. Just like in the case of a shipping container, when we see a shipping container, we will get a picture that okay, something is there within with all the required things. Similar way, when you see a image, basically it's a file inside the container registry, then that means you can deploy that on any platform. So the container registry may have a version, so that means it's an immutable one, and you can deploy that to any platforms, provided if it has a container runtime in place. So you don't have to bother about whether that image will work properly in that environment or not, or whether it has additional dependencies, runtime dependencies or anything. So nothing has to be bothered on that, because everything will be there within the application inside that Docker file, so that the runtime platforms just need that Docker file and it will run or spin up the application based on whatever it is configured inside that Docker file. Then so far we have discussed about the most advanced model like the Kubernetes services, like the Amazon EK service. Also Red Hat also provide on such similar service called the Red Hat OpenShift services. Red Hat has different models. They do provide standalone versions which you can install on your data centers or on the edge machines. Similarly, they provide a cloud version from Red Hat as well. And Red Hat also provides other cloud versions like the AWS or Azure versions as well. If you look into the Red Hat service, Red Hat OpenShift service, you can see it's a bit more advanced than the Kubernetes itself, because to make it as a complete feature, they have integrated everything. We will be having a session, a discussion on the Red Hat OpenShift service in a future episode. So recently I have attended one of the Red Hat OpenShift seminars, and I have gone through some of the features they provide, and I think I can have a session a bit later. So that way they also provide the Kubernetes version of their own. Then Azure also provide their own versions. Then basically it's the Kubernetes service, but the benefit that you get from a cloud provider are on-demand scalability and a declarative model where everything will be taken care of by the cloud provider. You don't have to bother about the cluster management and all. So these are the two kinds of commonly used patterns which I have seen: the Kubernetes service as well as the serverless container models like the AWS Fargate. So which one to choose when? That's a question, because most of the cloud providers do provide Kubernetes version as well as independent, and also as independent container instances as well. Say for example the Azure container instances. It's a light version of container runtime where you can simply run a container instance, and it's suitable for running batch jobs and all. And you will be charged only for how much time it's actually running. So if your application has a set of a fewer say for example, if you have an application where you have some UI screens, then you can deploy that onto some form of a service like app service or something, and then rest of the things you can host that in the minimal container runtime instances like the ACI or the AWS Fargate. AWS Fargate is serverless in the sense that it's actually not suitable for long running tasks. So if your task is a bit long running, say for example more than 10 or 15 minutes, then having that on in the serverless may not be a good choice. You can have that as a kind of a batch container jobs in some other services like as a sidewise of Elastic Kubernetes services. So Red Hat also provides some form of batch job running options so that you can run along with the Red Hat OpenShift service. But if you want a very minimal version, then it will be better to have some form of a lightweight versions like container instances, standalone version. Then so these are most of the enterprises use mainly for, and if you then by going into the Kubernetes platform, you will get additional benefits like logging and everything integrated within the Kubernetes, persistent storage, automatic failover mechanism, everything will be service mesh, and everything will be taken care of by the Kubernetes itself. When you go to much lighter versions, then the features will reduce accordingly. Means if you go to the AWS Fargate, there won't be any provision for the other options like the storage or any other mechanism. So you have to manage it by yourself in that case. Then if you want more control over a container application, then you need to have some form of a virtual machine in cloud in place. You can have that in your own data centers as well, and you can install the different container runtimes on those instances, especially the container runtime that is compatible with the OCI standard. You can install that, and your Dockerized application can be run inside that container instances. So these are some of the very common scenarios. Then some services like some enterprises required a kind of a hybrid approach where they want to have Kubernetes run inside their on-premise scenarios. In that case, Amazon offers a service called Amazon EKS Anywhere, which offers kind of an on-premise Kubernetes service. But in the case of Amazon EKS Anywhere, Amazon provides the required software and all, so that you can install that on your on-premise systems. But the cluster management and the infrastructure management is the responsibility of your organization if you are choosing the Amazon EKS Anywhere. So you won't get any benefits of the initial on service which we discussed, like the Amazon Elastic Container Services. In that case, everything will, including the cluster management, will be taken care of by the Amazon. But in the case of Amazon EKS Anywhere, they will provide the software and the required software agents and everything, but you have to manage your infrastructure and the cluster accordingly. So the need depends upon where you want to deploy, what your application demands. Cloud providers offers different services, just like you have seen, and at the time of you listening this episode, maybe on a later date, then might be there more features coming up. So it will be good to check out the documentation of AWS. Especially you can search for the some keyword like AWS containers, so that you will get an idea what all services they do provide at that point of time, and you can leverage that. With that, we can wind up this session. There will be an upcoming session on the Red Hat OpenShift which is coming up. So thank you everyone for listening this episode. Have a great day.